So in this class, we are going to understand the importance of frequency response analysis through Bode plot, which is a technique, one of the techniques of frequency response analysis. So here, uh, so let us first study about what is a frequency response. So frequency response is the steady state response that are output of a system when the input to the system is a sinusoidal signal. So the magnitude and phase relationship between the sinusoidal input and the steady state output of a system is termed as the frequency response. So in the system transfer function, uh, consider T of S if S is replaced by J omega, when the resulting transfer function T of J omega is called as the sinusoidal transfer function. So in the frequency response method, the frequency of the input signal is varied over a certain range and the resulting response is studied. So a system causes both the amplitude and phase angle of the input to be changed. Therefore, the system itself can be represented by a complex number. So the product of input phasor and system function is the phasor representation of the output. So there are some of the advantages of frequency response analysis, which include the absolute and relative stability of the closed loop system can be estimated from the knowledge of their open loop frequency response. Then the practical testing of the system can be easily carried with available sinusoidal signal generators and precise measurement equipments. So the effects of noise disturbance and parameters variation relatively easy to visualize and incorporate corrective measures. The frequency response analysis and design can be extended to certain nonlinear control system. And the transfer function of complicated system can be determined experimentally by frequency response test. So these are the advantages that are obtained during frequency response analysis. So there are some of the frequency domain plots which include Bode plot, Nyquist plot, and Nyquist chart. So Bode plot is one of the important and easiest method of frequency analysis. So this Bode plot is introduced by H.W. Bode, which was first used in the study of feedback amplifiers. So it is one of the popular graphical methods used for determining the stability of the system when the system is subjected to sinusoidal input. The stability of the closed loop system is determined based on the frequency response of the loop transfer function of the system. The gain or magnitude and phase angle uh, of the system can be easily represented as a function of frequency using Bode plot. The Bode plot consists of two graphs. One is the log plot of the magnitude of a transfer function and another one is the phase angle plot. So the magnitude plot, it is the plot of the logarithmic magnitude or gain of the loop transfer function in decibel versus frequency omega. That is m is equal to 20 log of log g of j omega h of j omega in dB versus omega. And the phase plot is the phase plot, the plot of the phase angle of the open loop transfer function versus frequency omega. Phi is equal to angle g of j omega h of j omega versus omega. So there are some reasons for using the logarithmic scale in the Bode plot. That is one of the reason is that the variation of frequency in a large scale is easier if we use a log scale rather than the ordinary scale. And there is also another reason, that is in higher order systems, magnitude of individual subsystem have to be multiplied to get the magnitude of the higher order system, which is a tedious process. But if we are using the log scale, the multiplication part can be replaced by the addition. That makes the process of determining the magnitude of the higher order system, it's easier. And so these are the reasons that why we are using the log scale in the Bode plot. And there are also some advantages and disadvantages in using the Bode plot. So some of the advantages include the expansion of frequency range of a system is simple, and the experimental determination of transfer function of system is simpler if the frequency response of the system is shown using a Bode plot. Polar plot and Nyquist plot can be constructed based on the data obtained from the Bode plot. And there are some little bit disadvantages in Bode plot, which include it is possible only to determine the absolute and relative stability of the minimum phase system. Corrections are to be made in the obtained plot to meet the desired frequency plot.